Today's test method covers ASTM D4318, the standard test methods for liquid limit, plastic limit, and plasticity index of soils, also known as the Atterberg limit tests. First, we will have the standard liquid limit device, also known as the Casa Grande apparatus. This will aid us in getting the blow counts. Next, we will need the grooving tool used to make a standardized groove in the soil pat. We will also need a couple of moisture content cans for moisture content determination. We will need a water bottle so we can add moisture to our soil. We will need a mixing bowl to prepare our soil, a spatula to mix our soil, a mortar and pestle to crush the soil. We will also need a scale to record the weights of each test. The plastic limit is defined as the moisture content at which a material begins to act less like a plastic putty and more like a brittle solid. In order to conduct the plastic limit test, the following will be required. We will need a glass plate to roll out our 3mm threads on. We will need a rod that is 3mm in diameter to gauge when we get down to 3mm. We will need 2 cans to get moisture content, and we will also need a spatula to spread and dry out our soil. In order to produce the flow curve, 4 liquid limit tests must be conducted. One test between the blow counts of 15 and 20, another between the blow counts of 20 and 25, a third between the blow counts of 25 and 30, and finally one between 30 and 35 blow counts. As the soil dries out, the moisture content is reduced. This results in stiffer soil. To perform the liquid limit tests, weigh out about 300 grams of the provided soil. If the soil is clumpy, you can break it up in the mortar and pestle equipment. Start by adding water from the water bottle to the soil sample and mix the soil until it appears uniform and the surface looks creamy. Please note that a proper blending could take up to 20 minutes. Once this step is complete, then determine and record the empty weights of the 4 moisture content cans, which will be used later in the test for moisture content determination. Casa Grande apparatus is easily knocked out of calibration, so it is important to calibrate the device often. The grooving tool has a block on the back of it that is exactly 10 mm tall, the fall height of the Casa Grande cup. Calibrate the apparatus by placing the grooving tool underneath the cup. Rotate the handle so that the cam just contacts the cup. If the apparatus is calibrated, the cam will just barely touch the cup, and it will not lift it off of the grooving tool. Loosen the set screw on the top and adjust the thumb screw in the back to raise or lower the cup. Thoroughly clean and dry the cup. Evenly spread a moderate amount of soil into the cup to create a soil pat to be tested. Using the grooving tool, create a straight groove through the center of the soil pat. The shoulders of the grooving tool should just scrape the surface of the soil pat. If the shoulders of the grooving tool do not contact the soil pat surface, then that means you did not put enough soil in the cup, and the test should be restarted. Once the groove has been made, rotate the handle at 120 revolutions per minute, 2 cycles per second, and count the number of blows it takes to close the groove in the soil pat. 13 mm or 1/2 inch, which is the width of the grooving tool handle. If the number of blows falls between 15 and 20, scoop out some of the soil and place it in one of the pre-weighed moisture content cans and record the new weight for moisture content determination. Then place the moisture content can with the wet soil in the oven and reweigh it again in 24 hours. If the number of blows falls below 15, then your sample is very wet and you need to mix the soil and dry it out. Then clean and dry the cup to repeat the test. If the number of blows is above 20, then your sample is very dry and you need to add moisture to the soil, then mix it again and then clean and dry the cup to retest the sample. You will need to repeat the procedure to get test results between 20 and 25 blows, 25 and 30 blows, and 30 and 35 blows. Once this is complete, you will need to plot the moisture content versus the blow counts and determine the liquid limit from the flow chart. With the moisture content plotted in the vertical axis and the blow counts plotted in the horizontal axis in the log scale, a linear regression can be established through the data and the liquid limit can be interpolated. The plastic limit is the average of the moisture content when the soil starts to crumble when it is being rolled into a 3mm thread. So you will need to take a 25 to 30 gram sample and spread it on the glass plate to dry it out or to a workable state. Once it is in a workable state, you can then pick it up and start working it in your hand. Next, you will start rolling the soil into a thread. You will roll the soil until the diameter of the thread is reduced to 3 millimeters. Use the rod so it can be a gauge to determine when the soil has reached 3 millimeters in diameter. If the soil does not crumble when rolled down to 3 millimeters, you will need to dry out the soil and try again. Once the soil crumbles at 3 millimeters, collect the samples of the crumbling soil and then place them in the pre-weighed moisture content cans for moisture content determination. You will then repeat the test enough times so that enough soil has been obtained for 2 moisture content samples of approximately 6 grams each. Record the wet weights of the moisture content samples and place in the oven. Then you will reweigh the samples again in 24 hours. The average of the 2 moisture contents is the plastic limit.